Hi, welcome to 1.3 maximum or minimum of a quadratic function. Our learning goal, we will be able to determine the zeros and the max or min of a quadratic function and solve problems involving quadratic functions, including problems arising from real-world applications, such as bridges, projectiles, or maybe revenue questions. Our success criteria, we can move through the various forms of a quadratic. Okay, so in a moment, we're going to talk about the three different forms for quadratic, and we need to be able to move between those various forms. And our second one is to be able to find the maximum of a quadratic by either completing the square, something we will need to review, and partial factoring, something new that we will need to learn. Okay, here are the three forms for quadratics. We have standard form, ax squared plus bx plus c. We have our factored form, and we have our vertex form. Okay, and they're all really helpful. They all give us certain pieces of information which allow us to make a nice, pretty graph. Okay, standard form, what is it good for? It can give us the y-intercept. Okay, when x is 0, if we were to plug 0 in for x, these terms go away and all we're left with is the constant term. So our y-intercept will always be the constant term, and we can see that in the graph right here. In factored form, we get the x-intercepts. Those will look like r comma 0 and s comma 0. Okay, what that means is if we plug r in for x, okay, something special will happen in this bracket. If we plug r in, we're going to have r minus r, and this whole term goes to 0. Okay? So when this bracket is 0, because we're multiplying it by everything else, the whole thing will go to 0. Okay? This is making reference to the zero property theorem. Okay? What this theorem says is a times b equals 0 if and only if a is 0 and or b is 0. Okay, so we'll plug that in there. Okay, you can't multiply two numbers together and get 0 without any of them being 0. All right, so again, to go over this x-intercept, s0, if we plug s in for x, okay, over here it's going to give us some value, but when we plug it into here, s minus s, this is going to go to 0, making the whole function go to 0. Okay, when the function equals 0, it turns into an x-intercept, like we can see here on the graph. All right, and now vertex form. This gives us the vertex, h comma k. Remember, this number is always the opposite to what you see in the bracket. Okay, and knowing the vertex is really good for helping us find the max or min of a quadratic. Okay, then the only other thing we need to know is whether this opens up or down. So if you remember, if a, okay, this is actually referencing this a here and this one in all three equations. If a is greater than 0, then this opens up, we can say, opens up. Okay, and that means if it opens up, okay, our vertex h comma k is, that's a k, h is a minimum. Okay? And if a is less than 0, well then this opens down, and what happens is our vertex is a maximum. I'm just going to write a max for short, okay? So if it opens down, our vertex obviously is going to be the highest point on the graph. Okay, I think we are ready to get started. Just one other thing I'm going to review. With quadratics, we also have something called an axis of symmetry. Okay, and I write it as AOS for short. It just means the axis of symmetry. Okay, and what's special about it is if this was a piece of paper and you fold it along the dotted line, this branch would map over directly onto this one, okay, if you were to fold it. So it shows the symmetry in the graph. All right, we're going to see that this is going to come helpful to us when we start doing partial factoring. Okay, and I'll reference it as AOS for axis of symmetry. The axis of symmetry does have an equation, and it's always x equal to, and it's the value in the vertex, the h value, x equal to h. Okay, so that's the equation of this line. Okay, let's move forward a bit. Before we start learning how to move between the forms, we have to review a couple concepts. So if we're going to go from standard form all the way to vertex form, we have to do something called completing the square. Okay, it's kind of like factoring, except when we factor this, we don't get two binomials, we actually get a binomial squared. Okay, and we'll go over that process very soon. To go from standard to factored form, you might have guessed, all you got to do is factor. Okay. Now to go the other way, if I wanted to go, let's say, from vertex form, and I wanted to move to standard form, well, all I have to do is expand. Okay, so I can take this here, expand, and then collect the like terms. Okay, same thing with factored form. I'm just going to connect those because that works the same way. Okay, if you got factored form like this, when you want standard, then we need to do FOIL. We got to expand in the brackets and then collect our like terms. Okay, we don't really ever go from factor to vertex, but if you had to, you first going to put it in standard and then complete the square. Okay. All right, so in order to complete the square, this is a great way for getting the vertex. We need to first go over perfect square trinomials and how to factor them. Okay, perfect square trinomials, they have this form. Okay, and I can recognize them because the numbers on the end, or the terms on the end, are perfect squares. Okay, we can see that here. The first and last term are perfect squares. Okay, because we can take the square root of a squared and get a, and b squared we can get b. Okay. So the other pattern comes from the middle term. Okay, the middle term here is always 2 times the square root of the first term times the square root of the second term. Okay, so you can see here the square root of the first term is a, so we have an a here, and the square root of b squared is b. So our middle term is just 2 times a times b. Okay, that's following this pattern here. Okay, just to make sure this is clear, in that example, we would have 2 times the square root of a squared, the first term, times the square root of b squared, the second term. Okay, this is going to give me 2 times ab. Right? So I always do that for a check. I want to make sure before I factor that something's a perfect square, so I look for that pattern. All right, the second one is just listed underneath here because sometimes instead of having a positive here, we have a negative. And that's okay, we can still factor this and we would still get something here. So if this is negative, then we're just going to get the negative sign in the middle over there. All right, so let's look at these next ones. We want to factor them, and we just want to first check to see if it's a perfect square. So I'm going to go ahead and do that. I'm going to square root the first one, and I get x. I'm going to square root 144, and I get 12. Okay, multiply those together, and then double it. Yeah, I get 24x. That works. So this is definitely a perfect square trinomial. Okay, so that middle term needs to be equal to 2 times the square root of the first term times the last. Okay, and yes, I get 24x. Okay, I'm not going to always do this when we look at perfect square trinomials, so I'm just going to jump right to it. So factoring it is really easy. Once you've done this check, we've already done all the groundwork. We've rooted the first and last term, and that's really what goes in the bracket. Okay, the next thing we got to do is just steal the sign here. Remember, if it's positive, then we got positive in the middle. If it's negative, then we got negative. So we're going to take that positive value. So that's it in factored form. If you don't believe me, then you can do a check. You can do FOIL for this. Write this out. okay, and do your distributing, collect all your like terms, and you're going to see you get this pretty polynomial that we had at the start. Okay, the next one, square root the first term. Square root of x squared is x. Square root of 81 is 9. Okay, I want to check, so I'm going to take 2, I'm going to multiply it by the square root of the first term, which is x, times the square root of the second term, which is 9. And yeah, I get 18x. Yes, I know this one's negative. Well, that's fine. All that means is when I factor it, I'm going to have a negative in the bracket. Okay, so let's write it out. We're going to have x minus 9 squared. Okay, and that's it. As simple as that. All right, can you make these perfect square trinomials? Okay, what would we have to have here for those? Okay, pause the video if you want and try to figure those out. Okay, welcome back. That second term here, well, it's kind of easy. I just need to take this and I got to reverse my process. I'm going to divide by 2 and then square the number. Okay, so for this one, 10 divided by 2 is 5. 5 squared is 25. Okay, same with this one. I would have negative 10 over 2, and then I got to square it. Okay, negative 10 over 2 is 5, negative 5. And when I square negative 5, I get 25. Okay, that's how that works for those. Okay, so this means for the quadratic x squared plus bx plus c to be considered a perfect square trinomial, the last term c must be equal to the middle term over 2 squared, b over 2 squared. And that will, if we see that pattern, we know we have exactly a perfect square trinomial. Okay, now let's take a look at completing the square. So in order to complete the square, we're basically going to factor something that doesn't look like a perfect square trinomial, and we're going to manipulate it so that it does. And when we manipulate it, when we factor it, we'll then get vertex 1. Okay, so essentially we're taking a trinomial and manipulating it to look like a perfect square trinomial. So we'll be using this concept of the last term, setting it equal to b over 2 squared. All right, and yeah, once we get good at that, we'll then know how to move from standard form to vertex form. So here are our steps. Put the first 2 terms in brackets. So when you're given your trinomial, let's say it looks like this, just says put the first 2 terms in brackets. Okay. Step B says common factor the leading coefficient from the first 2 terms only. So if you have a 1 for the first term, you don't really need to do this step. Okay. Step C, it says add and subtract a b over 2 squared inside the brackets. This creates a perfect square trinomial. Okay, and then we're going to factor the perfect square trinomial, and then we're going to expand and collect like terms. Okay, I put here in a little note, it says skip a and b if the leading coefficient is 1. So that's what we have in this first example, 1. So we're actually going to be able to skip these first 2 steps and just jump right to C. Okay, let's go ahead and do this. So we need to add and subtract a b over 2 squared. So I wrote here inside the brackets, you're only going to have brackets if you're doing steps A and B. If you're skipping them, well, you don't have any brackets, you can just add it at the end. Okay, so we're going to take this here, and I'm now going to add a b over 2 squared, and I'm going to subtract 1. Okay, by doing this, I'm creating a perfect square trinomial here. Okay, and notice when I add 1 and then when I take 1 away, I'm not changing the value of the polynomial. Okay, we still have the plus 11 at the end, so notice these actually could just cancel out and I have the same thing. Okay, I don't want to cancel them though, I want to utilize this because that's a perfect square trinomial and I can factor that. Okay, in my next line, let's plug in what I got for b over 2 squared. So we have x squared plus 6x plus, okay, this is my b term, the 6, so I'm going to have, plus 6 over 2, which is just 3 squared. Okay, so we're going to add and subtract one of those. Okay, so this is actually just 3, and this one is just 3. Okay, and my next line, we're going to have x squared plus 6x. Okay, so 3 squared is 9, and then minus 3 squared, minus 9. And we solve our plus 11. Okay. All right, so now we have our perfect square trinomial. Okay, we're going to factor this. It's just going to be, remember, we take the square root of the first term, x, and then we're going to take the square root of the second term, 3, and then we're going to write it as squared. Lastly, we just steal our sign and we put it in there, plus. Okay, that perfect square trinomial is now factored, and we just have the minus of 9 and the plus 11 at the end. Well, that's cool. That's really easy. We can just perform that operation. Negative 9 plus 11, well, that's just 2. And this polynomial is now put in vertex form. We just finished completing the square. So that's how we would move from standard form to vertex form. Okay, let's try it with these functions. Okay, first example, find the vertex by completing the square. State if it's a minimum or a maximum or minimum. Okay. All right, so my leading coefficient is 1 for this one. So I get to skip steps A and B. I'm just going to add and subtract a b over 2 squared. Okay, and we still have the plus 7 at the end. Okay, I'm writing a little bit too big. I got to move this over so that I can do the next question. Okay. All right, my b is 5 in this case. So we're going to fill that in. Now, when you do these questions, if you want, you can go off to the side. You can do your b over 2 squared, okay, which would just be 5 over 2 squared, and then you can calculate that. And then you can just plug them into here, okay? So since I'm already kind of started this here, I'm just going to finish it. So 5 over 2 squared, well, we got to apply the exponent to the top number and the bottom number. So 5 squared is 25, and 2 squared is 4. So that's what that would equal. Okay, I'm going to go ahead and replace this now into here and here. Okay. All right, x squared plus 5x plus 25 over 4. Okay, I can't simplify that, unfortunately. So it is what it is, but that's okay. We can deal with it. And believe it or not, this is a perfect square trinomial. So whenever we follow this b over 2 squared rule, we're creating perfect square trinomials. So I'm just going to highlight that part here. That's a perfect square trinomial. Okay. So we then want to factor that. Okay. So that's going to look like the square root of the first term, x, the square root of the second term. Well, the square root of this is actually what we had before we squared it up here, just 5 over 2. So we can steal that. We'll write plus 5 over 2. Okay, I know it's plus here because that's plus, right? Okay, so that is the perfect square portion. Okay, I'm just going to highlight that in blue. Okay, so that's this part factored to this. Okay, now we just got to take care of these constant terms at the end. We want to collect like terms. We need to add them. We got to make this a fraction, right? With the same denominator over here. So I'm going to have to multiply the top and bottom by 4. So it's going to look like we got minus 25 over 4 plus. I'm going to have to multiply this by 4 and the bottom by a 4, right? That way I have a common denominator. So 7 and 4 is 28. So I have 28 over 4. Okay, our last line. Negative 25 plus 28. Well, that's just 3 over 4. So there we have it. We just converted our first standard form function into vertex form. Okay, we still need to, we still want to state the vertex, and we want to state the vertex and then state if it's a max or a minimum. Okay, so my vertex is going to be the opposite sign of this. It's always the opposite sign, minus 5 over 2. And there's my y value, 3 over 4. Okay, my a value for this, well, a is actually 1, so it's positive. So that means this is going to open up. So a is equal to 1. Okay, and then we can say since a is greater than 0, we can say the parabola opens upwards. Therefore, negative 5 over 2 must be a minimum. So I just kind of explaining the reasoning and how we got this part here. Okay, our a value is a positive 1, so it's got to open up. Okay, let's do this next one together. I was going to say, why don't you go ahead and try it, but we got a nice ugly fraction here, so it's probably best if we do this one together. Okay, so we don't have 1 in front here this time. Okay, so if you remember the rules, it says put the first 2 terms in brackets and then the common factor, the leading coefficient from the first 2 terms only. Okay, so let's go ahead and begin this. So first step, put the first 2 terms in brackets. Okay, that plus 5 is feeling alone right now. It's the only one stuck outside. Okay, step 2, common factor out the leading coefficient, okay, on the first term. So we want to factor this out. When we factor out, we're actually dividing. Okay, so this is going to be a little bit of the tricky part. Okay, I'll get it started, but then I'll show you how we're going to figure that out. So if I were to factor out negative 2 over 3, I'm dividing it out of these terms. Okay, now that's pretty easy. When I divide negative 2 over 3 out of the first term, I'm just getting rid of the coefficient, and I'm going to have x squared. Okay, but the next part is not so easy. What's 8 divided by negative 2 over 3? Well, we got to figure that out. Okay, so I'm just going to change colors for this here. So I'm trying to figure out 8 divided by negative 2 over 3. Well, if you remember, when we're dividing by a fraction, okay, we need to flip and multiply. So this is the same thing as doing 8 times 3, negative 3 over 2. Okay, it doesn't really matter where the negative goes, right? Whether it's on the top or bottom, it's still going to make everything negative. So 8 times negative 3 over 2, we're going to get negative 24 over 2. And that's nice. That works out to just negative 12. Okay, so I now know what to put in over here. I can write minus 12x and then close the bracket. Okay, the reason for doing this first step is I now made this look like this here, which is similar to what we just did. Okay, I got to get that leading coefficient to be 1. So we do a common factoring of negative 2 over 3 from the first 2 terms only. Okay, now we get to move on to step 3. Add and subtract a b over 2 squared. Okay, so let's figure out b over 2 squared first. Okay, this is my b term right here. Okay, you don't want to grab b from up in the original equation, right? Because we've been changing it as we move through. We want to use this one. Okay, so don't make that mistake. Okay, we're grabbing that b value, which is negative 12. Okay, negative 12 over 2, that's just negative 6. Negative 6 squared is 36. So we're going to add and subtract one of these, right, inside the bracket. So let's go ahead and do that. So I'll change colors to show that part. So we added a b over 2 squared, so we're adding 36, and then we got to take 1 away. Okay, we got to do that because we can't change the polynomial. By adding something and taking away the same thing, we're essentially keeping its value the same. The only thing is we're changing its form. Okay, and by doing that, we're creating that perfect square trinomial that we need. Okay, let's go ahead and factor. All right, so remember we square root the first term, we get x. Square root the last term, we get 6. Okay, and remember we have to use the sign in here. This is going to be negative. Okay, all right. And like I said before, the shortcut, well, why don't you we can just grab the number from here even, right? Okay, and don't forget that plus 5 at the end, right? Oh, wait, sorry, we are missing something here. Okay, we have to institute another set of brackets. So just because I factored this, I can't forget about that piece right here, that negative 36. So I don't want to just say minus 36. I have to put some brackets around here and keep this contained. Okay, so if you want to think about it, like if those brackets were up here, okay, all we did was factor this first part, and that goes here, and then we still have this negative 36 in here. Okay. The reason why it's important to keep them in brackets is because this negative 2 over 3 is being multiplied by this entire bracket. Okay, so if I just take this negative 36 out, well, I have to multiply it by this first to do that. Okay, that's why we have these square brackets. All right, our next step is to distribute this in. Okay, so we're going to multiply this negative 2 over 3 inside the brackets. This is our first term. And then to our second term right here. When we do that, we'll drop the square brackets. So multiplying this in first, we're going to get negative 2 over 3 times x minus 6 squared. And then we got to distribute again to the next term. Okay, we're going to have minus 2 over 3 times 36. Okay, we still have our plus 5 at the end. So whenever we expand like we just did, we always get to drop the brackets. Okay, 36 divided by 3, I can simplify this right here. 36 over 3, that's just 12. Okay. So I'm just doing that to help me in the next line so that I can collect all the like terms. Okay, negative 2 times 12 is negative 24, and then we have plus 5 at the end, so that'll just be negative 19. Okay, and that is done. That is, I know that was quite a few steps, but that's converting this ugly, okay, quadratic. I'm calling it ugly just because we got a negative fraction, leading coefficient. This is basically like worst case scenario. And we have completed the square and we have successfully put it into vertex form. Okay, we just have to write out the vertex like the question asks. So we can say the vertex, we'll say therefore the vertex is, remember it's always the opposite sign, 6, comma, and then our last term, the negative 19. Okay. A is equal to negative 2 over 3. Okay. So we could say since A is less than 0, this opens down. Therefore, 6 negative 19 is a minimum point. All right. Okay, we could actually really draw a nice graph from this, just from getting the vertex, and even from the standard form, we have the y-intercept. Okay, so that would be some good information to have if we were graphing. Okay, I'm going to pause this video for now and we'll resume it in the next video.